Okay. Good evening, everyone. This is the ninth live discussion session of Soil Mechanics and Geotechnical Engineering 1. Only one person have joined, and I'll start the class now. It's already 5. I'll go to the PPT screen. Yes. So, yes, Ravindra Kumar, is the PPT visible?
Yes, sir. Yes, sir. Visible, sir.
Okay, yes. Okay. Another one has joined.
Okay. All right. Please,
Please, please unmute yourself. Please mute yourself. Sorry. Please mute yourself. Rupesh
मेरा चल
Kumar.
रहा है? मेरा चल रहा
Rupesh Kumar, please mute yourself. Okay. So, like the previous weeks, I'll start with the discussion. I'll first dictate some questions. You first write down all the questions, and I'll give you some time to solve the questions. After the break, I will start discussing the answers, and I'll also discuss the concepts behind the solutions. So, I'll start with the dictation of the questions right away. This is the ninth live discussion session, and the topic is consolidation and time rate of settlement. So, consolidation part has already been discussed in the last week. This is the class where we discuss about the settlement of soils due to consolidation. Okay, I start. Okay, it is recording. Yes. Okay. So write down the questions. It consists of MCQs, true false statements, and many numericals. First, write down the questions. Okay. The first question is: the ultimate settlement of soil is a function of. The ultimate settlement of soil is a function of. Your options are coefficient of volume change, increment in effective pressure, thickness of the soil layer, or all of these.
all of these, sir.
No need to answer the question, you just write down the question and you solve it. I'll give you some time. Afterwards, we'll discuss about the solutions. Okay, I'll repeat the question once. The ultimate settlement of soil is a function of. The options are coefficient of volume change, increment in effective pressure. Those who have joined late, please write down the questions. This is the first question. I'll give you some time to solve these questions and then I'll discuss the solutions. I'll repeat the question. The ultimate settlement of soil is a function of coefficient of volume change, increment in effective pressure, thickness of the soil layer, or all of these. Okay. Next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. I repeat the question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. Okay. Next question. Consolidation settlement can be computed by using. Consolidation settlement can be computed by using. The options are coefficient of volume change, voids ratio, both of the above, or none of these. I'll repeat the question once. Consolidation settlement can be computed by using. The options are coefficient of volume change, voids ratio, both of the above, or none of these. Next question. It is a true false statement. Final settlement is small in case of pre-consolidated soils, as the recompression index is very small compared to the compression index. Final settlement is small in case of pre-consolidated soils, as the recompression index is very small compared to the compression index. What are pre-consolidated soils? Soils which have been consolidated in the past to the certain degree of pressure to which it has been exposed in the present. Final settlement is small in case of pre-consolidated soils, as the decompression index is very small compared to compression index. Is this statement true or false? You have to answer. I'll repeat the statement once. Final settlement is small in case of pre-consolidated soils, as the recompression index is very small compared to compression index. Is this statement true or false? You have to answer. Okay. Next question. From now the numericals are starting. Please write down the data very carefully. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. There is a load or the pressure is applied. After some time, the pore pressure is found to be 0.60 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. I repeat the question once. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. So the data here is the pressure, initial pressure applied is 2 kg per centimeter square. The pore pressure after some time is found to be 0.6 kg per centimeter square. You have to find out the degree of settlement for this pore pressure, that is 0.6 kg per centimeter square, given that the ultimate settlement is going to be 20 millimeter of this clay specimen. Mind it, the clay specimen is fully saturated. If there is any doubt, you can ask regarding the question, or else I'll move to the next question. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. Okay. Next question. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60%, estimate the settlement at the end of 5 years for the changed condition. I'll repeat the question once. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60%, estimate the settlement at the end of 5 years for the changed condition, that is for the single drainage condition. Okay, not the ultimate settlement. You have to find the settlement at the end of 5 years, considering less than 60 percentage degree of consolidation. Okay, next question. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, for which TB, that is time factor, equal to 0.196 in 1 year, determine the coefficient of consolidation. Determine the coefficient. Whoever is joining, please mute yourself. Determine the coefficient of consolidation. If the coefficient of permeability is 0.040 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. So in this question, you are being told to ask two different things. Firstly, you have to find out the coefficient of consolidation, and then you have to find out the settlement in 1 year. The clay layer is 8 meter thick. The pressure, initial pressure is 70 kilonewton per meter square. The layer has double drainage and the consolidation percentage 50%, for which time factor is given, that is 0.196 in 1 year. To find out the coefficient of consolidation, and if the coefficient of permeability is 0.040 meter per year, to find out the settlement in 1 year. The unit weight of water is 9.81 kilonewton per meter cube. If there is any problem in understanding the question, please you can ask or raise a hand in the meeting. I'll repeat the question once. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, with TB equal to 0.196 in 1 year, determine the coefficient of consolidation. Then the coefficient of permeability is 0.04 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. Okay, I'll go to the next question. A soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45%. The clay has a saturated unit weight of 20 kilonewton per meter cube, a particle specific gravity of 2.7, and liquid limit of 60%. Foundation load will be subjected to the center of the layer to a vertical stress increase of 10 kilopascal. The groundwater level is at the surface of the clay layer. Estimate number one, the initial and final effective stresses at the center of the clay layer. Number two, the approximate value of the compression index. And number three, the consolidation settlement of the foundation above the layer. Take the unit weight of water as 10 kilonewton per meter cube. So there is a soft consolidated layer of clay 20 meter thick with a moisture content of 45 percentage. Unit weight of 20 kilonewton per meter cube is the saturated unit weight. Specific gravity G equal to 2.7 and liquid limit of 60 percentage. This is the data of the clay layer. Now the load, there is a foundation load subjected at the center of the clay layer gives the vertical stress increase of 10 kilopascal, and the groundwater level is at the surface of the clay layer. That is, the clay is fully saturated. To find out the initial and final effective stresses at the center of the clay layer, the approximate value of the compression index, and the consolidation settlement of a foundation above the clay layer. The water has a unit weight of 10 kilonewton per meter cube over here. Okay. I go to the next question. Okay. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 millimeter settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. I repeat the question once. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 mm settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. I hope it is clear. You have to find out the extra time required to achieve a total settlement of 50 mm. Okay. Next question. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 to 300 kilopascal. That is, for 200 kilopascal increment, that void ratio decreased from 0.6 to 0.5. To find out the initial void ratio of the clay layer, the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. So you have been given the thickness of the clay layer and the average effective overburden stress is 150 kilopascal, and you have also been given the decrement in void ratio from 0.6 to 0.5 on increment of stress from 100 to 300 kilopascal. Using these conditions, you have to find out the initial void ratio of the clay layer and the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. I hope it is clear. Next question. At a given site A, having a clay layer 8 meter thick with a single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? So, what we need to find out, there is a clay layer at site A, 8 meter thick, single drainage. Now, it gave a settlement of 5 centimeter in 1 year, and that is corresponding to 50% of degree of consolidation. Another site B, same type of soil with a thickness of 16 meter exists. So for this soil, how long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if the field of the same magnitude at a site A was to be considered a site B? That means we need to find out the settlement magnitude and degree of consolidation and the time for 50% consolidation. Okay. Someone has joined. Okay. Please mute yourself and write out the questions. Yes. I repeat the question for someone who has joined now. At a given site A, having a clay layer 8 meter thick with a single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? Okay. Next question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one dimensional consolidation under a pressure increment of 20 kilopascal. The soil has specific gravity 2.7, natural moisture content of 45%, and compression index of 0.45 and recompression index of 0.05. The initial average effective stress within the soil layer is 100 kilopascal. Now determine the primary consolidation settlement of the soil layer. This sum is similar to another sum I have discussed before. The data for this sum is the thickness of the layer is 1 meter, the increment of pressure is 20 kilopascal, the initial pressure is 100 kilopascal, the specific gravity of soil is 2.7, natural moisture content is 45%, compression index is 0.45, and the recompression index is 0.05. Find out the primary consolidation settlement of the soil layer composed of saturated clay, and the soil is normally consolidated. Okay. All right. Next question. A 4 meter thick normally consolidated clay has an average void ratio of 1.3. Its compression index is 0.6 and coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to existing effective overburden pressure, calculate the settlement of the clay layer. What does it mean? The soil has a thickness of 4 meter and the average void ratio is 1.3. Compression index is 0.6 and the coefficient of consolidation is 1 meter square per year. Now, the existing overburden pressure, the existing overburden effective pressure is equal to the increase in the vertical pressure due to foundation load. So, the magnitude of initial effective overburden pressure is equal to the increment in vertical pressure due to the foundation load. Now, if that is the condition, you need to find out the settlement of the clay layer. Coefficient of consolidation is 1 meter square per year, void ratio is 1.3, thickness is 4 meter and the compression index is 0.6. Next question. In a consolidation test, the void ratio of the specimen which was 1.068 under the effective pressure of 214 kilonewton per meter square changed to 0.994 when the pressure was increased to 429 kilonewton per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility, and then find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kilonewton per meter square. So, initial effective pressure was 214 and the void ratio is 1.06. Incrementing pressure to 429 kilonewton per meter square, change the void ratio to 0.994. Using this condition to find out the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Now the thickness of the layer is 8 meter and the increase in pressure from the initial condition is 10 kilonewton per meter square. Using this condition to find out the settlement of foundation resting on the above soil. Is it clear? Do you have any doubt?
It's okay, sir.
Okay. Please copy the data very carefully. Okay, next question. A normally consolidated clay settled by a just copy it twice, ignore the mistake. Settled by 2 centimeter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and 800 kilopascal. So, when the effective stress of a normally consolidated clay was increased from 100 to 200 kilopascal, the settlement was 2 centimeter. Now, to find out the settlement of this clay layer in two cases. First case, when the effective stress is increased to 400 kilopascal, and in second case, when the effective stress is increased to 800 kilopascal, and it is increased from the initial condition, that is 100 kilopascal. So when the effective stress is 400 kilopascal, what will be the settlement? And when the effective stress is 800 kilopascal, what will be the settlement of this clay layer which has settled by 2 centimeter when effective stress was increased from 100 to 200 kilopascal? Okay. Next question. Simple question. A saturated soil has a compression index of 0.28, void ratio at a stress of 12 kilonewton per meter square is 2.05, and the permeability is 35 into 10 to the power minus 7 mm per second. To find out the change in void ratio, the stress is increased to 21.6 kilonewton per meter square, and the settlement in the first case, the soil is 6 meter thick. So the soil has a compression index of 0.28. The void ratio at the initial stress of 12 kilonewton per meter square is 2.05, and the permeability is 3.35 into 10 to the power minus 7 mm per second. Now when the void ratio, now when the stress is increased to 21.6 kilonewton per meter square, to find out the change in void ratio, and also to find out the settlement given that the soil is 6 meter thick. Okay.
Sir,
Yes.
permeability is 35 or 3.5, sir?
35, 35. 35 into 10 to the power minus 7.
Okay, sir.
Okay. Next question. An undisturbed sample of clay 24 mm thick, consolidated 50% in 20 minutes, When tested in the laboratory with drainage allowed at top and bottom, the clay layer from which the sample was obtained was 4 meter thick in the field. How much time will it take to consolidate 50% with double drainage? If the clay stratum has only single drainage, calculate the time to consolidate 50%. So, the sample of clay is undisturbed and is 24 mm thick. When allowed for double drainage, it consolidated 50% in 20 minutes. Now, the clay layer in the field was 4 meter thick. So, how much time will it take to consolidate 50% with double drainage in the field? Okay. And the second part is for single drainage, you to find out the time taken to consolidate 50%. So, in two cases, one is a field condition with the same drainage condition, that is the double drainage, and the second one is the field condition with single drainage. In both the cases, the degree of consolidation is 50%. Okay. Okay. Next question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Assuming double drainage, how long it will take to attain half the settlement under the load of a structure? It's also a similar question. The thickness is 2 meter. The coefficient of consolidation is 2 into 10 to the power minus 4 cm square per second. Now, assuming double drainage, you have to find out the time taken to attain half the settlement under the load of a structure, half the ultimate settlement. Okay. Okay. Next question. Two identical clay samples of same sizes designated A and B are subjected to consolidation test under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. So, there are two identical clay samples of same sizes A and B. The consolidation tests are carried out under identical conditions except the fact that drainage takes place through one phase in sample A, that is single drainage, and through both phases in sample B, that is double drainage in sample B. It takes 10 minutes for 50% consolidation in sample A. How much time will it take for the same condition, that is 50% consolidation in sample B? Okay. I hope the questions were clear. Those who have not copied all the questions might wait. I'll discuss the question after some time. And those who have copied all the questions, you can start writing. You can start solving the questions after some time. It is another 15 minutes. I'll start discussing the solutions. Okay. So 15 minutes from now on, I take 40. I'll start around 5:55. Okay. Hello. Kindly mute yourself.
हाँ बोले ना प्लीज। आ गया। बंद करना पे। हाय रुपेश।
Is the PPT visible?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, okay, okay. So I'll start discussing the answers. Okay. The first question was the ultimate settlement. The soil is a function of. What is the answer? Someone has mentioned it previously.
All of these.
Yes, all of this. Why? The ultimate settlement. If I write the formula, the ultimate settlement is if it is rho f, then rho f. The formula is mv del sigma h. Okay. So mv is the coefficient of volume change, del sigma is the increment in effective pressure, and h is the thickness of soil layer. So the ultimate settlement is a function of all of these. Good. All right. Next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. What is the answer?
Degree of consolidation.
Yes. Settlement at any time, let it be rho t, and ultimate settlement, this is the final settlement, this is the rho f into 100% will give us the degree of consolidation. Okay, good. Okay, next question. Consolidation settlement can be computed by using, what is the answer?
Both of the above, sir.
Yes, you can also you can find out the settlement using the coefficient of volume change is mv, and also using the void ratio is e. So using both the methods in the laboratory, we can find out the settlement during consolidation. So both of the above. Good. Final settlement is small in case of pre-consolidated soil. There's a decompression index is very
False.
small compared to compression index. Why? Why false?
True, sir.
Yes, it is true. Why? Because the recompression index, that is the CS, that is the swelling index, is almost equals to 1.5 to 1.10, 1/5 to 1/10 of the compression index, that is CC. And compression index is a part of the formula where we find out the settlement. We can see in the next numericals and all. So the settlement, that is the what we say del h, if we have done the settlement, it is directly proportional to the compression index and the recompression index. So final settlement in case of pre-consolidated soil, in case of pre-consolidated soils, there is also this dependency of del h with the recompression index, due to which cs being much less than cc, we get small final settlement in case of pre-consolidated soils. Okay, so yes, recompression index is very small compared to compression index, due to which final settlement is small in case of pre-consolidated soils. Okay, okay. Next question. Have you solved this question? Okay, if not, I'll write it down. I will not waste any time. Okay, so the main concept behind this is when the ultimate settlement is happening. Okay, when the ultimate settlement is happening, what will be the effective pressure? The effective pressure will be equal to 2 kg per centimeter square. The ultimate effective pressure will be equals to effective, that is dash, will be equal to 2 kg per centimeter square. Why? Because at the time of at the time of entire consolidation being happening, the pore pressure will be reduced to zero. But right now at this time t, at this time t, the effective pressure is how much? At the time when at which we are supposed to find out, is 2 minus 0.6 total pressure minus the pore pressure, that is equals to 1.4, 1.4 kg per centimeter square. Okay, so 1.4 kg per centimeter square. So if 2 kg per centimeter square is giving us 20 mm settlement, okay, so we can write like this: sigma t dash by sigma f dash will be equal to the degree of settlement, and that degree of settlement will be equal to how much? Will be equal to rho t divided by rho f. T divided by rho F. Rho T is the settlement at this time, and rho F is the settlement at the final, that is the ultimate settlement. So rho T upon interchanging sigma T into rho F by sigma F, that is 1.4 divided by 2 into 20, it will give us 14 millimeter. So the corresponding value of settlement at the time when the pore pressure is equals to 0.6 kg per centimeter square is equals to 14 millimeter. Is it clear? Because both this gives us U. Okay, I hope it is clear.
Yes, sir.
Yeah, okay. I'll go to the next question. Yes, have you solved this? Anyone have solved this? Has anyone solved this question?
So I am late, sir. I didn't do it.
Okay, no problem. Okay, first of all, final settlement where is the percentage? Should to be less than 60%. Okay, settlement at the end of 5 years. Yes. So in this case, if we write U, that is the degree of consolidation, 9 centimeter, and final will be 45 centimeter. Okay, 9 to 5, 45, that is 9 by 45 into 100 will give us how much? 20%. Okay, 20% is the degree of settlement in 5 years. Okay, detailed scientific investigation indicates that only single drainage occurs. You are asked to find out the degree of consolidation to be less than 60%. Settlement in India for 5 years. Okay, considering single drainage. Okay, so now we know that time factor, this TB equals to CBT by D square. CBT by D square. D means H by 2 for double drainage, right? D means H by 2 for double drainage. Now for this case, we can find out the value of TV, right? We can find out the value of TV. What is the value of TV? What is the formula to find out TV from the degree of consolidation?
Pi by 4 u squares.
Pi by 4 u square. Using that formula, TV equals to how much? Repeat. Equals to pi by 4 u square, right?
Yes, sir.
Pi by 4
Point
u
two.
square. Yes.
Point two.
So using that formula, you can find out the value of TV, and then you can find out the value of CV. You can find out the value of CV because see, in this question, the depth of the soil is not given, thickness is not given. So I'll write like this: CV by H square equals to, okay, it is given, time is given in 5 years. Time is given in 5 years. So the CV by H square will give us a value of around 1.57 into 10 to the power minus 3. First understand, you can solve it later if you don't have to solve it now. Understand this concept, you can solve it later. Okay, so this is the value of CV by H square. Now details and investigation have indicated single drainage. So now for single drainage, we know TV equals to CVT and D is equals to H. Please mute your mic. And D equals to H CVT by H square. Now for single drainage, we can find out, that is CV by S square we know, okay, and T is equals to 5, and equating this with U, that is this is equals to pi by 4 U square. Why? We are asked to consider the degree of consolidation to be less than 60% even in the case of single drainage. From this, we can find out the value of U because T we know 5 years, CV by H square we have calculated from the previous equation, and the value of U will be get approximately equals to 10 percentage. Okay, approximately equal to 10 percentage. Now we have to find out the settlement. So the final settlement is how much? Final settlement is 45. Okay, so rho divided by final settlement 45 equals to 10%. It is 10 by 100. It is 10% means 0.1. Yes, 0.1. And so rho will be equals to how much? Rho will be equals to 4.5 centimeter. Okay, rho will be 4.5 centimeter. So it was 9 centimeter based on double drainage. If it is single drainage, the settlement will be 4.5 centimeter as solved using these equations. Is it clear? Okay, I'll go to the next question. There are many sums to solve. Okay. Has anyone solved this question? You are being given the thickness del sigma, that is the pressure increment. Time factor you have been given 0.196, time is 1 year, and K is 0.04 meter per year. So for double drainage, using the formula, that is TB equals to CBT divided by H by 2 whole square, you can find out the value of CB. Okay, find the value of CB. CB will be equals to how much? Equals to almost equals to 3 point. What you are asked to find out? Determine the coefficient of consolidation. Yes, 3.136 meter square per year. You get around this. Okay, because PV is 0.196. Okay, time is 1 year, and H is 8. Okay, H is 8. So you'll be getting CV. Now coefficient of permeability has been said. So you have to find out the MV first. Okay, coefficient of compressibility, of volume compressibility is MV equals to, what is the formula? MV equals to K by CV gamma W. Okay, K has been told 0.04, CV we have found out 3.136, and gamma W is 9.81. We'll get a value of MV as 1.3 into 10 to the power minus 3, and what is the unit? It is meter square per kilo Newton. Coefficient of volume compressibility, meter square per kilo Newton. Now using this MV, we can find out what? We can find out the settlement. This is the ultimate settlement. Okay, rho F. What is the formula? MV del sigma into H. MV we have just found out. Del sigma is how much? A pressure of 70 kilonewton per meter square. This is del sigma. Okay, and H is 8 meter. We'll get MV as 0.728 meter. 0.728 meter. Now for this is the 100% consolidation. So for 50% consolidation, this is when U equals to 100%. So it will be half of this, 0.364 meter for U equals to 50%. And why did I consider 50%? Because we are told to do so. We are told that it undergoes 50% consolidation in 1 year. So settlement in 1 year will be equals to 50% consolidation settlement, that is equals to half the ultimate settlement. That is 0.728 divided by 2, 0.364. Clear? Okay, I'll go to the next question. Okay. Has anyone solved this question? I explained the question previously. Those who have not joined, those who have joined late, please write down the question and try to understand. I'll just explain the solutions right now. So here we are asked to find out first the initial and final effective stresses. How to find out the effective stresses? Anyone? We are asked to find out the stress at the center of the clay layer. Okay. So 20-meter thick, center of the clay layer means it is 10-meter height, isn't it? So the initial stress, that is, if I write sigma 0 effective, will be equals to how much? Will be equals to effective stress, that means submerged weight, that is gamma submerged, gamma saturated minus gamma w into h, that is 10. This is gamma submerged, right? That will give us 100 kilonewton per meter square. And obviously the increment in stress is 10, so sigma final, initial and final effective stress is sigma final effective stress will be equals to 110 kilonewton per meter square or kilopascal, whatever. Okay, this is the initial and final effective stress. Now the approximate value of compression index. This is very easy. Compression index formula we all know, 0.009. From the first few chapters we have learned 0.009 into liquid limit minus 10 to liquid limit minus 10. What is the liquid limit? It has been told 60% is 0.60%. You will take over here 60 minus 10, that is 50 into 0.09 will give us a value of 0.45, isn't it? 0.45 value of compression index. Now to find out the consolidation settlement, this is the main formula to find out the consolidation settlement. Del H equals to Cc divided by 1 plus E0, 1 plus E0 H, that is initial height, log to the base 10, final pressure, that is after increment by initial pressure, effective pressure. Now the question is how to find out E0. What is the formula? E0
AC equal to WG.
Wg by S, it is saturated, so S equals to 1. It will be W sat, that is the saturated moisture content into G. You will get around 1.215. G is 2.7, moisture content is 45%. Okay, so putting the formula of E0, this is E0, initial void ratio. Cc is 0.45, E0 is 1.2, 1.215, yes, 1.215. H is 20, the total thickness of the layer. Sigma F, final pressure is 110 and initial pressure is 100. You will get around the value of settlement to be around 16.8, 16.82 centimeter. Okay, I hope it is clear. So you can understand the basic index properties, and soil classification is so important for the entire course of geotechnical engineering or soil mechanics, because we have index properties formula over here to find out the settlement of soils during consolidation. Okay, I hope it is clear. I go to the next question. 20-meter thick clay layer sandwich between silty sand. Okay. Okay. So when we are say sandwich between silty sand and gravelly sand, what does that convey? Single drainage or double drainage?
Double drainage.
Yes, very good.
Double drainage.
Yes. So first of all, you have to find out the value of time factor in the formula CBT by H by 2 whole square. Okay. Coefficient of consolidation CB is 0.03. 0.003. Time is 2 years. Convert it into seconds. 2 years to seconds, and take h by 2, 20 by 2 equals to 10 meter into 100 centimeter. You'll get a value of around 0.189. Wait, the TB value will be around 0.1892. Why did you find out time factor? Okay, to find out the degree of consolidation over here. Okay, so considering the degree of consolidation to be less than 60%, TB equals to how much? TB equals to pi by 4 u square, from which we can get the value of u. The value of u to be equals to 0.4908. In percentage, it is 49.08 percentage. So we are right, it is less than 60%. The assumption was correct, isn't it? Now, having said that the assumption was correct, we have to find out what? We have to find out the extra time required for the settlement. Now, this is a complicated sum because time is involved over here. What we can do over here is we have to first find out rho by rho f, that is just a minute. Yes. So u equals to, we know, settlement by final settlement, or experience a settlement of 30 in 2 years. So what is going to be the final settlement? Rho f will be how much? Final settlement will be how much? Rho by u. Rho by u. Okay. So rho, that is the settlement in 2 years, is 30 mm, and u, the value of u will write over here 0.4908. The value we get over here is approximately, yes, 61.12. 61.12, and it is in millimeter. Okay, so this is the ultimate settlement. Now, extra time required for the soil to achieve a total of 50 mm settlement. For 50 mm settlement, what will be the degree of consolidation then? 50 divided by ultimate, that is rho f. It will be how much? The degree of consolidation will be equals to 81.8 percentage at that time. 81.8 percentage, that is the degree of consolidation. And using another formula, that is TB equals to, now if 30 mm settlement is 49% consolidation, 50 mm settlement will not be, might not be less than 60. Okay, okay, it is given 81.8 percentage, so we'll use this formula only because it is more than 60%. The formula is 1.7813. Can anyone say the formula of TV when U is more than 50%, 60%?
1 -1 log minus u.
Your voice is breaking. Okay, I hope you said the correct answer. 0.9332 log to the base 10, 100 minus u, right? Log to the base 10, 100 minus u. So, using this formula, we find out the value of TV. And the value of TV is, using this formula, TV is 0.6054. Okay, 0.6054. Now TV is also equals to what? TV is also equals to CVT divided by D square. D square means H by 2 whole square. H by 2 whole square. And using this equation, you can find out the time to be equals to in years. Convert the entire time in years. It will be equals to how much? I think entire time is 6.4. Yes, 6.4 years. Okay, 6.4 years. So 6.4 years it will take for 50 mm settlement. So extra time taken, 6.4 minus 2, that is del t, is equals to 4.4, isn't it? Del t equals to
Yes.
4.4. So after 30 mm it will take 4.4 years more to reach up to 50 mm settlement. Okay, I hope it is clear.
Yes, sir.
Yeah, okay, just a moment. index. Next question. Okay, in this question, you have to first find out the value of E0 because the value of E0 is not given. I think yes, initial void ratio is the first thing to be found out. So, as we know, Cc equals to del E divided by log to the base 10 sigma 2 by sigma 1, isn't it? Sigma 2 divided by sigma 1. Now, what is del E for the first case? Del E is void ratio decrease from 0.6 to 0.5. Del E is 0.1 and sigma 2 is 300, sigma 1 is 100. To find out the value of Cc. Cc equals to how much you will get? You will get the value of 0.21. We find out the coefficient. We find out the compression index first. Okay. Using this compression index now at 0.6 it was 100, right? At 0.6 it was 100 and 150 is the average. What? 150 is the average initial uh, stress on the soil. So you write like this: E and sigma. Make a chart like this. So when E equal to 0.6, sigma was equals to 100. When E equals to E0, actually sigma was 150. So the initial void ratio was less than 0.6, isn't it? So again, using the same formula, you write del E equals to how much you will write? You will write 0.6 minus E0 and this sigma 2, what will be sigma 2? Sigma 2 will be 150, sigma 1 will be 100 in the second case, right? This is sigma 1, this is sigma 2. And solving that equation, this equation, same equation, you will get a value of E0. Value of E0 will be 0.563 approximately. So the initial void ratio you find out first by finding out the compression index of the soil. Okay, this is the first question. Second question was the total consolidation settlement of the clay to construction of a structure. Okay, this is very easy question. Once you find out E0, then del H, that is the settlement of soil, equals to Cc divided by what? Cc divided by 1 plus E0, okay, into H, 10 meter thick, log to the base 10, additional stress intensity of 200 kilopascal. So after adding 200 to 150, you'll get 350, right? The final pressure is 350. 350 the final pressure, and the initial pressure was how much? 150. Solve it, you'll get a value of around, the del H will be, it will be approximately 0.5. Approximately it will be 0.5 meters settlement. Okay, so due to an additional stress intensity of 200 kilopascal, the total settlement during consolidation will be approximately 0.5 meter. Clear? Okay. Next question. At a given site A, okay. Yes, so you're asked to find out how long it will take for 50% consolidation, that is the time, and also what will be the magnitude of settlement, that is the settlement uh, value of the site B, isn't it? So okay, first of all, for the same degree of consolidation, that is for the same U, T1 by T2 will be equals to H1 by H2 whole square. H1 by H2 whole square. Why? Because we know that TV equals to CVT by, if it is single drainage, it is single drainage, yes, single drainage by H square So even if it is double drainage also, we can find out the correlation like this. Time will be equals to how much? Time will be equals to CV into TB into, sorry, not CV into TB. Time will be equals to TB divided by CV into H square. So the same degree of consolidation, the same kind of soil, TB will be constant and CV will be constant. So T equals to a constant into H square. So T1 by T2 equals to H1 by H2 whole square. From this you can find out the value of T2. What is the value of T2? T2 will be T1 into H2 by H1 whole square. T2 will be equals to T1 into H2 by H1 whole square. H2 by H1 whole square. What is the value of H2? H2 is 16, H1 is 8, given in the question. H2 is 16. And what is the value of T1? T1 is 1 year. T1 is 1 year. So now 1 into 16 by 8, that is 2 whole square 4. So T2 will be equals to 4 years. It will take 4 years, okay, if 4 years for the site at B, that is the same magnitude as site A was to be considered as site B, it would have taken 4 years for that site because of the difference in the thickness of the soil layer, first of all. Okay, now also we know settlement, that is rho equals to final settlement mv del sigma into h, it's a height. So if I say rho A by rho B, okay, I'm guessing 1 and 2 with the rho 1 by rho 2 will be equals to how much? Will be equals to H1 by H2, or rho 2 will be equals to rho 1 into H2 by H1. Okay, now what is the value of yes, what is the value of H2? H2 is 16, H1 is 8. What is the value of rho 1? That is 5 centimeter. So 5 into 16 by 8, that is 5 into 2, or rho 2 will be equals to how much? It is equals to 10 centimeter. Rho 2 will be 10 centimeter. Is it clear? We are equating directly the settlement with the thickness of the soil layer, and also we are equating directly the time taken with the thickness of the soil layer using a square relationship obtained from this equation, and this obtained from this equation. Okay, so if a field of same magnitude as at site A was to be considered site B, the thickness, the difference in thickness would have made a change in time and a change in the settlement of the soil. Okay, all right. Next question. Okay, anyone have solved this question? Has anyone solved the question? Prashant, Rupesh, Ravindra, Abdul. Okay, you're asked to find out the primary consolidation of the soil layer. So first of all, the initial void ratio will be equals to Wg by S. When S is saturated soil, E will be equals to W into G, that is 0.45 into 2.7. Again, similar value like the previous question, 1.215. Okay, now we need what? We need the coefficient of compression. We need the compression index also. Del E divided by log to the base 10 sigma 2 by sigma 1. Okay, so here the coefficient of the compression index is given, sorry, the compression index is given, and the decompression index is this. So the first thing is, do we need the decompression index in this question or not? We don't need the decompression index, I believe not. Yes, we don't need the decompression index because it is a normally consolidated clay. Had the question being pre-consolidated clay, okay, then we would have required the decompression index. Right, now why are we calculating del E? That might be a question. We can also find out using this equation, that is rho equals to Cc divided by 1 plus E0, okay, sigma 2 by sigma 1, that is H into log to the base 10 sigma 2 by sigma 1, that is initial final by initial average is this one, 120 by 100. Yes, H, I'll just solve it. Please solve this equation. Cc divided by 1 plus E0. Yes, you can use this equation and find out the respective settlement to be 16.08 millimeter, or you can also use the del E, this del E, because we know that is del H by H from the compression from the consolidation texting is equals to del E divided by 1 plus E0. Using this formula also you can find out del H is equals to rho. What is del H? Settlement. What is rho? Settlement. So using this formula also you can find out, if we find out the del E, and using this bigger formula, the main formula also, you can find out if we use the compression index directly. Okay, this is the same formula, just interchanging the parameters over here. Okay, is it clear?
Yes. Yes, sir.
Yeah, good. Okay, next question. 16.08, 16.07 with the answer, something like that. Next question. Okay, same thing, same question. E is equal to 0.6, I believe. Normally consolidated clay, average void ratio of 1.3. Yes, 1.3. Compression index is 0.6. Coefficient of consolidation CB. Okay. Yes. The main thing in this question is, when you are writing del H equals to Cc by 1 plus E0 H log to the base 10. So if initial pressure is sigma, okay, then the increment in vertical pressure will also be sigma divided by the initial pressure, because what has been mentioned over here, it has been mentioned over here that the vertical increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure. So existing effective overburden pressure is sigma, then the increment is also sigma, so it will give log to the base 10 2. So sigma sigma cancel, it will give us 2 sigma by sigma, it will give log to the base 10 2. H, the value of H is equals to 4 meter. E0 is also given 1.3, Cc is also given 0.6. You find out the value of del H. I think it will give us a value of around 314 millimeter. I hope the concept is clear. The main funda was to make you understand that the increment in vertical pressure due to foundation load is equal to the existing effective overburden pressure. What does it mean? It means if the initial pressure is sigma, the incremental pressure is also sigma, that gives us the final pressure as 2 sigma. So 2 sigma by sigma, that is 2, that is Cc by 1 plus A0 H 1 plus E0 H into log to the base 10 2. Okay. I hope it is clear. It was a simple question, just a trick in the end. Okay. Next question. Yes, in consolidation testing, first of all, you have to find out the coefficient of compressibility. What is the formula for the coefficient of compressibility? AB equals to del E divided by del sigma, right?
Yes, sir.
Yes. So del E will be how much? 1.068 minus 0.994. Del sigma will be 429 minus 214. You will get a
Three
value of,
point.
yes, 3.442, right? 3.44, something like that, into, to convert 10 to the power minus 4. I believe it will be meter square per kilonewton. Meter square per kilonewton. Okay, AV. Now what is uh, the
MV.
value of compression index? Yes, CC. CC is how much? CC is del E, again del E by 1 plus E0. What is the value of, sorry, not 1 plus E0,
Log of.
Log
log to the base 10,
sigma 2 by
yes, very
3.
good. Log to the base 10 sigma 2 by sigma 1. 1 plus E0 is for the settlement formula. Yes, log to the base 10 sigma 2 by sigma 1, that is sigma 2 is 429, right? Sigma 1 is 214 and del E is 1.068 minus 0.994, around 0.245, right? Value of CC. Have you solved it?
Yes, sir.
0.245. So first and second is done. Third is coefficient of volume compressibility. That is the MV. MV is how much? It is AV by 1 plus E0. Coefficient of compressibility divided by 1 plus E0. So AV we have found out. What is the value of E0? E0 is 1.068. So we get a value of around 1.664. 1.664 into 10 to the power minus 4 meter square per kilonewton. Okay, this is the value. And then at the end, settlement of foundation, increment of pressure. Again, the same formula for settlement. What is the formula? Equals to Cc by 1 plus E0 H into log to the base 10 sigma 2 by sigma 1. What is the value of sigma 2 now? Sigma 2 will be 214 plus 10, because it has been mentioned increase in pressure 10 kilonewton per meter square. So 214 plus 10 will be the, please mute yourself, there is a noise. 214 plus 10 divided by 214. H, the value of H is how much? The value of H is 8 meter thickness. Cc we have calculated. E0 we know. E0 is 1.068. So using this formula, you can find out the value of rho, that is the settlement. That is 18.8. Approximately it will be 18.8 mm. Okay, 18.8 mm. I hope it is clear. I'll go to the next question.
Sir,
Yes.
H is equal
Your voice is breaking. Please repeat the question.
del H. Can you calculate by using a MV delta sigma into H?
Del H, mv del sigma into H. Okay, let us see. So
Yeah,
del H, yes, when
when
you
I
have,
use I got 1.33 use.
wait, we'll see if del H equals
Okay.
to, because del H is the ultimate settlement. Okay, this is the ultimate settlement. This formula mv, what you are saying, del sigma, right, into
Yes, sir.
H, this is the ultimate settlement. So when you are using, just a minute, I'm just calculating, it is 1.664 into 10 to the power minus 4, right? mv
Yes, sir.
into del sigma. Del sigma is 10 kilonewton per meter square. 10 kilonewton per meter square into H. It is H. 0.133 meter, that is in millimeter. 18.8 is in millimeter. The it is into millimeter. 13.3 millimeter. So no, you cannot, because the ultimate settlement It means what? It means that the ultimate settlement, it will be getting at a load lesser than 10 kilopascal. Okay, and this has crossed the ultimate settlement. Okay, here we are considering the ultimate settlement when there is a time factor considered over there. Okay, in generally those cases, but in the case where the load is given specifically, we will not be considering the ultimate settlement because we don't know whether that kind of load will be leading to the ultimate settlement or not. If we say ultimate settlement, then only we'll be using this formula mv del sigma h. Clear? Is it clear?
Yes, sir.
Yeah. Okay, next question. Okay, have you solved this question? This is a very easy question. Okay, see, as I mentioned, del h or or rho whatever, cc divided by 1 plus e0, 1 plus e0 into h log to the base 10 sigma by sigma 0. Okay, now cc by 1 plus e0 into h, if this is taken as constant, it will be how much? It will be k into log to the base 10 sigma by sigma 0, isn't it? Now the value of k, what is the value of k? Settlement del h is how much? Del h is 2 meter. Sigma is how much? Final is 200 kilopascal. Sigma 0 is 100 kilopascal. K will be equals to how much? K will be a constant that is equals to 6.644. Same soil, same kind of properties everywhere. Now you use del h1 like this. Del h1 will be equals to how much? K into log to the base 10 sigma 1 by sigma 0, right? K into log to the base 10, because K means everything. Cc by 1 plus E0 into H. So K is K into log to the base 10 sigma 1 by sigma 0. Now what is sigma 1? Sigma 1 is 400 kilopascal. Isn't it? Sigma 0 is how much? Sigma 0 is 100 kilopascal and K is given. K we have found out. So del H1 will be equals to approximately 4 centimeter. Okay, same case you solve it for the next question and next part. Del h2 will be equals to k into, please mute yourself, sigma 2 by sigma 0, that will be equals to how much? Sigma 2 is 800 by 100, it will be equals to approximately 6 centimeter. Okay, sigma 2 is 800, sigma 0 is 100 and k is 6.644. Okay, clear? Okay, next question. A saturated soil has a compression index of 0.28. Compression index of 0.28. The void ratio at a stress of 12. Okay, so this is a very easy question. A change in void ratio. What is the change in void ratio? Del E, from the formula of Cc, del E equals to how much? Cc into log to the base 10 sigma final by sigma initial. Okay, or this is equals to Cc is given 0.28. Okay, 21.6 was the final value of the stress and initial was 12, isn't it? So 21.6 divided by 12 log to the base 10 of the fraction and multiplied by Cc, you will get around 0.0715, 0.072, 0.072, you will get the value of change in void ratio. Now the settlement, I have mentioned the formula previously, that is del H is equals to H into del E divided by 1 plus E0. This is the
Now,
formula. Yes, 1 plus E0. Then del E we have found out 0.072, 0.0715, whatever. E0 we know the value of E0 is how much? E0 is 2.05, isn't it? The void ratio at a stress of 12 km per meter square. It is 2.05. What is the value of H? What is the value of H? Value of H is 6 meter, isn't it? Value is 6 meter. So put everything in this equation. It is will be equal to 0.14 meter. Is it clear?
Yes, sir.
Is it clear? Okay. Okay. Just a moment. Three questions to go. Yeah. So in this case, again, undisturbed soil sample, double drainage, and then single drainage. Now for the same degree of consolidation, the time factor will be same. Again, I'll be doing the sum in the same case. T2 by T1 will be equals to D2 by D1, everything whole square. So T2 will be equals to how much? T2 will be equals to T1 into D2 by D1. Now what is D2? In the second case, D2 is the field condition, 4 meter thick. Okay. T1 is 20. Is it T1 is 20 minutes? D2 will be 4 meter thick. That is 4 by 2, 2 meter, 200 centimeter. Divided by 24 mm with double drainage will be 12 mm. That is 1.2 centimeter. You will get T2. The value of T2 will be approximately equal to 386 days. 386 days. T2 by T1 equals to D2 by T1 whole square. Now, again, for single drainage, very easy. T2 will be equals to how much? 20 into, for single drainage, it will be equals to how much? 4 meter or 400 centimeter. The same thing goes for laboratory case because it was 24 mm thick, and in the laboratory it was tested with double drainage. 400 by 1.2. I'm sorry, this is whole square. This is also whole square. Convert into days, you will get approximately equals to 1544 days. Clear? Time is directly proportional to the square of the drainage length. Okay, clear?
Yes, sir.
Okay, sir. Okay.
Yes. Next question. Have you solved this? This is very easy question. Again, in this question, considering the degree of consolidation to be less than 60 percentage, we use the formula of TV time factor equals to pi by 4 into u by 100, is the percentage if we can find out whole square. Okay, 100 whole square. Now it has been said that to attain half the ultimate settlement. So our assumption was correct because half settlement means, what does it mean by half
50%
settlement?
settlement.
Yes, 50% consolidation. So you put 50 over here, you will get a value of 0.197. 0.197. So the time for 50% settlement, it will be how much? It will be TV d square by cv. TV d square by cv. D is how much? D is h by 2. D d I'll just rub this. D will be equals to h by 2. 2 meter by 2 is 1 meter. This is 100 centimeter. TB is 0.197. CB is equals to, given 2 to the power of minus 4. You will get a value of approximately 114 days. Okay, 114 days. So the main thing to look out for here is half settlement. So this assumption will be based on the degree of settlement, because that will give us the degree of consolidation. Okay. Next question. This is a similar question. Please tell me how to solve this. Last question. Tell me how to solve this. We have only what? What information do we have over here? Anyone?
Degree of consolidation is same.
Same, and they are of same sizes, right?
Yes, sir.
So TA
Yes,
by
sir.
TB will be equals to what? DA by DB whole square, isn't it?
Yes.
DA by DB whole square. Now, if DA equals to H, because drainage takes place to one phase in sample A, so DB will be equals to how much?
Point 5 H.
0.5 H or H by 2.
Yeah,
So
both are.
H divided by H by 2, that is 4. TA by TB equals to 4, right?
Yes, sir.
TA by TB equals to 4. Hence, TB will be equals to TA by 4, isn't it? TA divided by 4. What is the time taken in the case of sample A? 10 minutes. 10 by 4 is how much?
Two and a half.
2.5. 2.5 minutes. Okay. So,
Yes, sir.
I hope this concept is clear. How to equate time with the drainage path when nothing is given or when small information is given. Okay.
Yes, sir. Yes,
Any
sir.
doubt? Any doubt regarding this session?
No, sir. Thank you.
No, sir.
Okay. Okay. Thank you for attending the classes. I hope the concepts were clear. We'll meet
Thank
again.
you, sir.
Yeah, we'll meet again in the next Sunday. Okay. Chalo. Thank you.
Thank you, sir.
Thank you.
Next chapter will be seer, sir.
Yes. Next chapter will be what?
Seer.
No, shear strength. I believe it was done. Next chapter will be earth pressure. Okay. Earth pressure. Shear chapter has been already completed, and the videos have been uploaded on YouTube, and the documents, the files have also been shared in the Google Drive. Please go through the materials given to you by the NPTEL coordinators. I believe they have sent you something, right?
This type of session I am asking, sir.
This type of session for the shear strength has
For
already,
seer.
yes, for shear has already been completed in the previous Sundays. You are not there, I think.
Okay.
You are absent. Okay.
Okay, sir. Yes, sir.
Yes. So Sunday, the sessions happen on Sundays from 5 to 7. Next Sunday it will be earth
Yes.
pressure 1. After that earth pressure 2, and then soil slope stability. Okay.
Okay.
Clear? Okay. So try to be present in the Sundays where you can get a clear idea of this kind of questions. Okay.
Okay, sir.
Okay. Okay. Chalo.
Right, sir. Right.
Bye. Yeah. Good night. Bye.
Thank you, sir.
Thank you, sir. Bye.